Okay, this is AP PreCalculus 2025 FRQ question number 3. This is going to be my sample answer and how I would answer the problem if I had to do so. So first we are going to read the problem. So it says, for a guitar to make a sound, the string need to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic function. At time t equals 0 seconds, point X on one vibrating guitar string starts at its highest position 2 millimeters above its resting point, then passes through its resting position and moves at its lowest position 2 millimeters below the resting point. Point X then passes through its resting position and returns to 2 millimeters after the resting position. The motion occurs 200 times in 1 second. The sine function h models how far point X is from its resting position in millimeters as a function of time t in seconds. A positive value of h of t indicates the point is above the resting position, and a negative value indicates the point is below the resting position. Part A, the graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated, and no axes are present. Determine possible coordinates for the 5 points below. So what I would do first is I would go ahead and try to label as much as possible. So we know that above the midline is a positive 2 and below the midline is a negative 2. And then we also know that from this beginning point here all the way to this ending point here is going to represent 2 seconds. Okay. Which means that this portion here is representing 1 full cycle of 1 second, and we know that this is going to go 200 times in 1 second, so 1 out of 200. And since there are 4 positions here that I'm trying to determine, I am going to first split this in half to label each of the 1 out of 200 attempts. So right here for J, which is the halfway point between F and P, I know that this value is going to be the halfway point between 1 over 200, which I could write as 2 over 800, which means that G is going to be at 1 over 800, and K is going to be at 3 over 800, and then P is going to be at 4 over 800, and F is going to be at 0 over 800. Okay. So once I have all of those labeled, I'm able to now depict what each of these points would be. So starting with F, I know F is going to be 0 and 2. G is going to be 1/800th to 0. Okay, J is going to be at 2/800ths to -2. K is going to be 3/800ths 0. And P is going to be at 4/800ths 2. And of course, these fractions could be simplified, so this could end up being 1 over 400 comma -2, and then this one being 1 over 200 comma 2. This way I just think is an easier representation of each of those coordinate points, so I just had them over 800, but of course it could always be reduced. So these would be my points for each of these 5 letters. Okay, let's see. Part B says the function h can be written in the form h of t equal to a sine of b of t plus c plus d. Find the value of constants a, b, c, and d. Okay, so in order to do that, we have to know what each of these essentially do to the function itself. So I am going to put part B over here. So we have h of t is equal to a sine of b, t plus c plus d. So first, we know a is the amplitude, which is the highest point or our max point on the diagram above. So since that's the highest point, we know a is equal to 2. Okay. D is going to be the vertical shift, and we can find that by doing max plus min over 2. So that's 2 plus negative 2 over 2, which gives us 0. So there's not going to be any vertical shift. And then to find B, we have to know that t is equal to the period of 1 cycle, and that t is equal to 1 over 200 because in 1 cycle it goes 200 times. And then we can use the formula for t, which is 2 pi over b, to find our b value. So this is 1 over 200 equals 2 pi over b, which implies b is equal to 400 pi. And then lastly, we have to find c, and c is the horizontal shift. So we need to shift. So the sine function starts at the midpoint, and we don't want it to start at the midpoint. We want it to start at the peak. So what we need to do to the sine function is we need to shift 1/4 of a period over. And again, that's since sine starts at the midpoint, or in our case 0, then goes to the peak. So if we were to have to shift this 1/4 of a period, then we do t over 4 is equal to t, which is 1 over 200 over 4, which is 1 over 800, which would be pi halves. So we would have to shift this pi halves, which means we would have the equation h of t is equal to 2 sine of 400 pi t plus pi over 2, and then plus 0, but we don't have to write that. So this would be our A, B, C, and D values. C says, refer to the graph of H in part A. The t-coordinate of G is T1, and the t-coordinate of J is T2. On the interval of T1 to T2, which of the following is true? So we got to find G and J. So we're now looking at this. This is T1 and this is T2. And we notice that this is decreasing, or it's a negative slope. So the only possible value could be D, that H is negative and decreasing. And then on C part 2, it says on the interval of T1 to T2, describe the concavity of the graph of H and determine whether the rate of change of H is increasing or decreasing. So here we're again looking at this graph, but remember when we're talking about concavity, we're seeing how the slope is changing. So notice as this is going down, we're starting at a small slope, but eventually we're going to start to turn in the positive direction, making this a positive slope, which means that this is concave up. So this is concave up, and we know that if something is concave up, then we know that the rate of change is increasing. So this implies that rate of change is increasing. And again, that was by looking at the graph above.